Can you weld with compressed air? How fine of a detail can you cut? Is the software hard to learn? How does it compare with the competition? Is it just a rebranded laser with the price marked up? Hey, welcome to the shop. Today I'm going to go over 30 of the most common or most interesting questions that have come in since I made my first two videos about the xTool MetalFab. If you want to learn more about the system and see it tested on a variety of materials and thicknesses for both cutting and welding, be sure to check out that first video. Let's get right into the questions. We'll start off by looking at questions about the CNC cutting features, then we'll look at welding, and then talk about the system as a whole. First question is, how small can the laser cut features be? Let's test that out on a variety of materials. I drew up a little test sample that I'm going to cut out that has a round and square feature that is 100 thousandths, 50 thousandths, and 20 thousandths in diameter. And I'm going to cut it out here first of this 1/8 inch thick aluminum sheet, and I'll repeat that on several different materials. So if you take a look, this is how it turned out. Pretty impressive. And I'm not going to show the measurements on all of them, but they were all within about 3 thou per side, and I just cut it on the line. I didn't do any kind of kerf offset, so you could definitely tune that in. So here is some 30 thousandths of an inch thick aluminum. I think this is a good fit for the gentleman who asked the question. He's actually working on some electronics enclosures. Now I'm moving on to some stainless steel, so you can see how this is on 16 gauge stainless. And this is some 14 gauge mild steel here that I'm cutting, and I'm just using compressed air rather than oxygen with it. I was probably traveling a little bit fast, so those couple of top slugs didn't fall out, but the detail's good. Now just for fun, let's try this out on 1/4 inch thick mild steel with these tiny little features, just cutting with compressed air. Now when I finished, that's pretty impressive if you ask me. I do have some dross because I was using compressed air. They actually recommend using oxygen, which won't have that dross, but I think the detail is quite good and the dimensions are good too. Look at those sparks. Bonus points if you can guess what this one is. This is some titanium. Definitely shouldn't be air cutting it, but even when I did, the detail came out really good. So I think it's safe to say that you can cut pretty fine features with this. I gotta say, that's pretty impressive to cut that level of detail on everything from 30 thousandths of an inch thick aluminum to 1/4 inch thick steel. The next question is, can you engrave or mark material? Well, we just did on that last test. Now, when the system first arrived here, they were still working on that, but it's been going for a little while. Let's try it out on a little bit bigger engraving and see how that turns out. Now I have this set to engrave my channel logo and then to cut around the outside. So, and I start the engraving, it rasters back and forth, and this is the real-time speed here. I'm used to running a galvo laser, and so I can run a lot faster, and because of that I can use a lot finer lines. Here I'll just speed it up a little bit so we won't be sitting here all day. It took about 3 minutes to work through my logo right here, and it's working just fine. It's just a little bit on the slow side compared to like a galvo laser. So you can see here, this is with the factory settings. I could probably dial back the power and increase the line density and improve it a little bit, but still not too bad. I showed xTool's air compressor and filter dryer in that first video, and a lot of people have asked if this system is worth it. This is the compressed air system. It's a 4-cylinder pump on this compressor, and it puts out 12 CFM, which is nuts for a machine that's this small, and it does run on 240 volts. It doesn't store much air in the tank because it can pump enough to keep up with the laser. And then this is the refrigerated air dryer. It has 3 stages of filtration. And I think what they've done here is a really nice job of considering the user, where space is at a premium. If you already have a nice compressed air system, go ahead and use that. But if you don't, I think it's a really good compact option. It is a little bit loud when it runs, but I think it's a good option. Now, some people have seen that there are different nozzles for the laser cutting feature on their website, and I've been asked, what are the different nozzles for? Let me show you. This is the standard nozzle. It just shoots a jet of air right at the workpiece, and this is recommended for higher pressures than their compressed air system puts out, so I'm using it in a manner other than directed here on that steel. This right here is their gas saver nozzle, and it has a little ceramic insert that actually drags along your material, and that forces more air down through the kerf to allow you to run lower air pressures, and that's what they recommend. This is the double nozzle right here, and it has that insert so that it sends a jet of gas down through the center. This one is for oxygen cutting on steel.
They recommend using oxygen for steel. We'll talk about that in a minute, but it uses this standoff along with that oxygen to give you an exothermic effect, and so it works well on steel also.
Now, xTool recommends using oxygen with their double nozzle whenever you're cutting steel that isn't super thin. And I've had people ask, can I use compressed air instead? And some people who have experience in laser cutting have even suggested that that can give better detail, and I've found that to be the case. In that last test we ran, I used both nozzles with compressed air, and they cut really well, not just the oxygen. So even though it leaves a little bit of dross or a little burr on the outside, I think that compressed air is totally viable for steel. Now, when you get into thicker stuff, or if you want to cut faster, oxygen can be a benefit and you don't burn through too much of it. Now, from my experience, either one works really well. That's not what they recommend, and so your results may vary. A lot of people have asked about the software. In my second video I made about this, I compared the workflow with my CNC plasma table, and that's a lot more cumbersome. This couldn't be simpler. You just load your drawing in or draw something in there, select your material. It shows an image of the actual material so you can drag it right in place, or it even has some auto nesting features, which work pretty well sometimes and less good other times. In my second video, you can see more about that. But then you just click to cut, and it does it. So I would say the software is one of the strongest points of this. In fact, I bought a different xTool laser about 1.5 years ago for my son for his small business. And the reason I chose xTool is because the software workflow was so easy on a different xTool laser that I've had here in the shop for a few years. So it's really a strong point, at least in my opinion. The next question is closely related. Can I import CAD drawings directly? Let me show you how easy that is.
So if you save out a DXF in millimeters and then click to open here, it comes directly in. I'll hide the background so you can see a little better, but it'll come in right to scale, so it'll cut it at the size you want.
Now we're moving on from the CNC cabinet to some handheld work, and the first question is, does it clean mill scale?
The answer to that is yes, and one of the coolest ways that I found to use it is use this little cleaning tip and just ride the edge of your material, and this can be a good joint prep for a bigger MIG weld right there to just remove the mill scale right where you need to. So it's pretty cool.
Now this one surprised me, but a lot of people asked, can you weld with compressed air? And my answer was no, right? Because the whole point of a shielding gas is to protect from the oxygen and other elements in the air so you don't end up with porosity or defects. But I hadn't tried it, so let's give it a go.
So this is just running with our compressed air system with the pressure turned down a little bit from cutting. And I'm surprised how smoothly this is running. Now, I don't think this weld is going to have optimal properties. I'll just say that right now, and I don't recommend doing this, but it turned out better than I expected. A little bit gray, but still, a whole lot better than I thought it could. Let's test it out and see if it has any strength to it, and I'm surprised that it's holding up as well as it is. Now, with other welds I've done on this thickness, it hasn't yielded there in the actual weld. So I want to break this open and see if there's some porosity in there that's really causing that to fail. And you can see some little bubbles in there, but it's a lot better than I thought. That being said, I don't recommend this. Just use some argon. It doesn't take very much to run your welds.
How easy is it to fill a gap?
Now, if you're an expert in welding a gap with a laser, please let me know what you're doing in the comments. I turned my scan width up, my power down, and my wire up a little bit, and I found that to work the best. And this is filling in pretty good until it isn't. What'll happen is I lose contact with the side, and then the gun will shut off. And so I have to work my way through, and then that'll happen again. And it can be a pretty frustrating endeavor. So I've found it to be pretty difficult to fill a gap because you don't have quite the same level of puddle control that you do with a TIG welder. That being said, I'm working on 16 gauge sheet metal here with a 1/8 inch wide gap, and I'm making my way through. So if you were in a bind and you had to, yeah, it can work, but it's not awesome.
A lot of people have asked, would this be good for auto body work? Because welding those thin panels can really be a pain with MIG, right? You're just putting a tack here and there, TIG, you've really got to space it out. Now, I'm not an auto body guy, and I'm not going to claim to know for sure, but I'll try running a butt joint on some thin material. This is 30 thousandths inch thick steel, and we'll see how that turns out. And maybe that'll give you an idea of whether it would be good for a patch panel.
Now, the little bit of auto body that I have messed with, I always ran it in, with little tiny tacks. So I'm trying that method here, but I mean, you move so fast that you cover a lot of ground with just a little bit of a tack. Now, you can go in a row. That's one of the frustrating things is when your wire gets stuck, but that's a setting and a little bit of technique. But here, if you just skip around, you can do that too. So we'll just see how this turns out. Now this is just 30 thousandths of an inch thick. So this is thinner than a lot of automotive sheet metal, but it's what I had on hand. And I think a little bit of a, kind of an extreme test to see how you can do with a butt joint like you'd have on a patch panel there. And I think that could be ground down. Certainly not bad with the good fit up that we had.
Can you demonstrate welding a 90-degree joint on some square tubing? Sure. Are fillet welds easier than groove welds? Yes, because it has a place for your wire to sit, but one comment that came in on another video suggested that I put a slight chamfer on my material for that wire to have a place to guide.
I thought that seemed like a pretty good idea, so I'm just touching it real quick there, not enough to create a real groove. Now, if I had a little bit larger diameter wire in there, it would probably fill in a little bit more completely, but I'm definitely getting full penetration. You can see the sparks coming through the back side there. And if you look, it's really not a bad result both on the face and full penetration on the root.
Can you weld over rust? Come on guys, clean your material, just do your prep. It doesn't take that long. You even have laser rust removal here. But since you asked, let's do it.
This is the nastiest material I had laying around in my scrap pile. I just got rid of a bunch of stuff that was worse than this, but we'll just run a few beads on plate here. Now you can see some areas where I cleaned this with the xTool laser cleaning feature, both handheld and CNC on my earlier video. So that definitely works well, and I'd recommend cleaning it up first, but this is actually running a lot better than I thought, and I think just that high energy is blasting a lot of it away. So certainly cleaner than a TIG weld over rust.
A lot of people have asked, is there a ground clamp? Well, the ground clamp or work clamp with a traditional arc welding process like MIG or TIG completes a circuit for an electrical arc, and you don't have an electrical arc in this case. So no, there's not in that sense, but you do have a small clip that attaches as a safety device so that the gun can sense when it's touching the workpiece to avoid accidentally firing off into the air. So you do still have a clamp, but it's for a different purpose. Can you rework a bad weld? If you do a bad job, can you just go over it? Let me try and make a bad weld and fix it.
Now that doesn't look too bad on the surface. There are some little artifacts from the weld before, and there's probably some defects buried in there that aren't going to be great structurally, but it's not bad.
Can you run multi-pass welds to build up your fillet weld size?
There's no reason you can't run multi-pass to build this up, and look at that beautiful little fillet weld there. And the benefit is that that penetrates deep into the plate, so it's going to be really strong. But the point of running a multi-pass weld would typically be to build up more material so you'd have a larger fillet similar to a MIG weld. And the deposition rate is just so low that even after running 4 passes on this, it hasn't built up very much material, and it's getting hard to track exactly where you are. So I don't think it's a good idea, but it's possible.
How hard are the weld settings to learn? So they've actually done a really good job with this. The thing I like about it is it has different layers. So there's the standard mode where if you just want to pick your material thickness, your wire, and then you fire it up, it's ready to go. I do wish they had finer steps or more resolution, like a 60 thou instead of just going straight from 40 to 80, or on the wires as well. These are coming off of metric conversions, but it's definitely workable. Now, if you want to get more into the settings, you can just go right here to click to your advanced settings, and that's, you know, more capable here to change things like power, your scan width and frequency, as well as your wire feed speed. But then if you want to really nerd out on it, you can click here to this professional version, and you have all of the settings. So depending on whether you want to have everything to work on, just your basic settings, or if you just want to say, just make it weld. And I found that these actually work pretty good. Does aluminum wire feed well? Well, I've had really good success feeding aluminum wire with this system, but I think it depends on the type of wire you use. I think the big issue here is the alloy and size of wire that you're trying to feed. See, this is 0.035 or 0.9 millimeter 4043, and it's just super soft and weak. So everything has to be sitting just right to be able to feed it without having it buckle and bird's nest. Now this right here is 5356 wire, which is much stiffer, and this is a 0.047 or a 1.2 millimeter, which is a much better size for this laser welding anyway, because it'll build up your fillet welds. It's very stiff. It's just as stiff as your thicker steel wire, and so you'll have no trouble feeding this at all. You could set up to feed this, but you're gonna have to keep your lead really straight, potentially change out to an inner liner or something like that to help it to feed a little bit better. What size wire are you using? I think bigger wire is beneficial because it just helps to build up that fillet weld size and add a little more reinforcement. So I've been using 045 steel wire, 047 aluminum wire, and it came with some 1 millimeter or 040 stainless steel wire, so I've used that for some stainless stuff too. Does laser welding create fumes?
Yeah, very similar to any arc welding process. You get some fumes, especially with aluminum. You can see just how much is coming off of the material here. So you need to have proper ventilation and a respirator and take those kinds of precautions even with laser welding.
Is this the only welding machine that I'll ever need? You know, people who are getting into metalwork or they want to get started want to know if this is just an all-in-one solution that covers everything. And the short answer to that is maybe, because it depends on the type of projects you want to make, right? People have asked me for the last 10 years that I'm doing this on the internet, should I pick MIG welding? Should I pick TIG welding? Should I pick stick welding? And I always have to come back and ask, what is it that you want to make? What is it that you want to do, right? If you want to cut flat sheet pieces and weld them together, I mean, this is absolutely golden. It'll do everything you need to. It's great for a lot of applications, but there are others that it's not quite as good for. So that's more than we can get into in this video, but just make sure the types of projects that you want to do are a good fit for laser welding, and a lot of them are. How does it compare to the competition? Is it just a rebranded laser like you'd get off Alibaba? Well, the answer to that is no. They've really developed not just a laser, but a whole system. The way that it integrates into the table, the software, the interface, it has support, it has documentation to guide you through every little step of the way.
You can get on their website, and there's a link in the description below where you can see more about the tool. But if you look at these tutorials and the documentation, I think you'll see how much effort they went to for the customer experience. While they're new to the welding and metalworking space, they have been at it for quite a while with laser engravers and have really become the leader in that space. So they're taking that product development expertise and just bringing it to metalwork.
I think you'll find that there's a lot of value in the user experience where you don't have to have another hobby learning how to use this. You can actually just make the thing that you want to for yourself or for your business. So just for example, let's compare the guns here. So this is a pretty typical gun that you'll find on a laser welder. If you look at how you have to remove the wire feeder here, you have these two different screws. This can pivot all around. You have all this other bulky stuff and nothing to support the cable, so it pulls on it in funny ways. Now, I'm not saying that this doesn't work. It definitely does, but it's not as well thought out. See here on the xTool, you just pop this open like a bicycle seat and it slides right off. And then when you put it on, slides up here. You have a line to index where it goes, and this attaches right there. Switching between modes, they've done their own little clips here. The tips slide on and off a lot faster. It has these wire feed controls here on the back, which is a nice touch. So overall, just some things are thought out, and that does add value even if the basic functionality is the same. A lot of people have asked, how is the customer support? This is my third xTool product. I've had a CO2 cutting laser here in the shop for a couple of years that's been awesome, and I've used it for all sorts of things. I bought a small laser for my son he has a laser engraving business, and he runs that every single day. And I picked it because of the workflow, and that's been trouble-free so far. I haven't needed any support or anything on this, so I can't really comment on how they deal with an issue because I haven't had one.
Something I didn't realize until just recently is they've done a lot to really build up the support network in the US. They have demo rooms. You can go and see the machines in person. You can schedule a material test to try out your parts. They have training, and they also offer machine commissioning on site included with every MetalFab purchase. So there's a lot there that you can get some help with.
Is it difficult to switch processes between welding and cutting?
So the CNC system and the gun have indexing pins to put it right in place in this clip that secures it really well, and then the cable management clips just pop out. And once you've removed the gun, you just remove that capacitive touch sensor and slide in the welding tube, and it has a little scale to set your focal length, and that's it.
What safety precautions do I need to take with this system? Well, they have a safety training online that I'd recommend going through before you pick up a system. In fact, it won't let you turn it on until you have gone through the full safety training videos and things like that. But you'll learn a lot in there about some of the hazards, and it's definitely something that you need to be careful with. I close my entire shop off, and I'm the only person in here, and so I treat that as my laser enclosure. That works because this is my own personal space, but if you are in a shared workspace or a commercial shop and you're dealing with different things, and you're really gonna have to consider how to make it work for you. Have you run into any issues with the machine? Nothing significant. So I've had it disconnect from the network a couple of times. I don't know if that's my internet issue or the machine issue. It's never happened while it's cutting or anything like that. I've never had an interruption, but every once in a while it'll jump offline and then return back. So that could be my network, that could be the machine. The only other thing that has held me up is I've received a warning for the temperature of the cutting head only when I've done a ton of cutting and only when I'm cutting steel with oxygen. And I think it's because I'm using that double layer, and there's such a slow flow of oxygen that you don't get nearly as much of a cooling effect on that. But it really wasn't any major issue. I just had to wait a little bit. Now, when I've been cutting with compressed air, I've done a ton of cuts in a row and never had that issue. So it was only with oxygen on steel. How does the consumable use compare with other processes? Well, the main consumables, of course, you have shielding gas and wire. Gas is going to be a little bit less than you'd use with TIG in most cases because you're traveling faster at a similar flow rate. So since your weld's done quicker, you're not flowing gas as long. Wire, you're also going to use less than you typically would if you were MIG welding something because you're able to make a smaller fillet weld than you would with a MIG weld. So you might save a little bit there, but those aren't really going to be any significant difference, at least compared to labor. As far as the machine itself, the main consumable item is going to be the protective lens inside the gun, and I've only replaced that once. So from my experience with my first laser, which isn't this one, I went through a ton of those, and that was user error because I didn't really know what I was doing. If you shoot straight into aluminum, or if you're running too low a power or things like that, it'll reflect back and you can burn your mirror a little bit, or not your mirror, your protective lens. In this case, with this machine, all of the cutting and all of the welding and everything that I've done, I had one where I shot right into some aluminum and psh, it was gone, low power, changed it out, it was great. I pulled it out yesterday to inspect it because I couldn't believe it was still running strong after so long, still in great condition. So you can get a lot of life out of these, but you can also mess them up in a hurry if you don't know what on earth you're doing. So keep that in mind. Now, the last question is one that I'm adding here, and that is, how does this machine make sense for a small business? I think that is the question. A lot of people want to use the space that they have to start something on the side. And I think that the capability that you have in this is absolutely 90% of what you need to actually produce products that you could sell. You know, for example, in that second video that I made where I cranked out that grinder rack, you could make stuff like that all day long at a really fast rate with this equipment. But just having the equipment and the capability isn't gonna make $100 bills rain down from the sky, right? You need to understand your customer, the need that you're meeting, and how you're doing that to better than the competition in some way, and then deliver that value and tell people about it. So I think if you put those ingredients together, this absolutely gives you the capability to produce your own product. Now, another place that I think it's gonna make a ton of sense is in existing small businesses. See, my dad had an auto repair shop, and that's where I grew up working. I loved it down there. We were always building custom cars, and I worked down there on some customers' cars, on cleaning the place, those kinds of things. And he would have bought this like that. It's a no-brainer for a place like that, because if you need some custom little metal part, it's as easy as printing it out, right? You can get it right away. And I think for those kind of applications, custom automotive stuff, even for like facilities maintenance, you know, I've worked in factories a lot, and the machine shops there, to be able to just crank out a part there for the tool room or those sorts of things without having to go and interfere with the production facility, you can just have that capability right there available is a no-brainer for the price of this machine. Now, I know it's a lot of money, especially on a personal budget, but in the course of a business, like an existing business, I think the value that you get out of something like this can make a whole lot of sense. Now, that was a whole lot that we covered here in this video. I do have an affiliate link down in the description below that helps to support making these videos. So if you are going to purchase it anyway, you can get it through that link at no additional cost to you, and it'll help me to be able to produce more of these videos and keep the lights on here in my little shop. Hey, thanks a ton for tuning in today. If you enjoyed this or learned something, let me know by hitting that thumbs up below. We'll see you next time.